There is a limitation on the length of conductors off the secondary side of a transformer before a disconnect switch is required. According to the National Electrical Code, specifically NEC 2020 Article 450.3 bone, a disconnecting switch is often required based on specific conditions related to conductor length and enclosure. The key aspects of this requirement are conductor length and whether the conductors are enclosed in a raceway or enclosure. NEC 2020 Article 450.3 bone stipulates that a disconnecting means is required when conductors are over 10 feet long or the conductors are not in a raceway or enclosure. In your case, the primary and secondary overcurrent protection is rated at 125% of the full load amps, meaning you will likely need to install a disconnect switch if the conductors off the secondary side of the transformer are over 10 feet long. The determination of whether a disconnect switch is necessary hinges on adherence to NEC regulations. A general rule of thumb to follow is that for conductors that are 10 feet or less in length, a disconnect switch is generally not required. However, if the conductors are longer than 10 feet, a disconnect switch becomes recommended to ensure safety and compliance. When dealing with transformers, understanding the NEC is essential for safe and compliant installations. Let's delve deeper into transformer secondary conductor requirements, specifically focusing on the National Electrical Code and how it dictates the necessity of a disconnect switch. The length of the secondary conductors from a transformer plays a crucial role in determining whether a disconnect switch is mandated by code. NEC Article 450.3 addresses the protection of transformers and includes specific requirements for overcurrent protection and disconnect. Article 450.3b pertains to the secondary side of the transformer, and it is here that the length limitation comes into play. If the secondary conductors are over 10 feet in length and are not installed in a raceway or enclosure, a disconnect switch is generally required at the point where the conductors leave the transformer. A raceway can be conduit, electrical metallic tubing, or other approved enclosures designed to protect the conductors. The absence of a raceway or enclosure increases the risk of physical damage to the conductors, making a disconnect switch essential for safety. The overcurrent protection rating of the transformer also influences the requirements for a disconnect switch. If the primary and secondary overcurrent protection is rated at 125% of the full load amps, as in your scenario, it emphasizes the importance of adhering to the length limitation rule. This is because a higher overcurrent protection rating may allow for longer conductor runs, increasing the potential for faults and hazards. It's crucial to consult the specific requirements outlined in NEC Article 450.3 bone to ensure compliance. Firstly, verify the conductor length. Accurately measure the length of the secondary conductors from the transformer to the first point of connection or overcurrent protection device. If this length exceeds 10 feet, the need for a disconnect switch is triggered, especially if the conductors are not in a raceway or enclosure. Secondly, check for raceway or enclosure. If the conductors are installed in a raceway or enclosure, the requirement for a disconnect switch may be waived, regardless of the conductor length. However, it is essential to ensure that the raceway or enclosure provides adequate protection against physical damage. Thirdly, consider local amendments and interpretations. While the NEC provides a national standard, local jurisdictions may have amendments or interpretations that add to or modify the code requirements. Consult with local electrical inspectors or authorities to ensure compliance with all applicable regulations. Fourthly, conduct regular inspections and maintenance. Regularly inspect the transformer and its secondary conductors to identify any signs of damage, wear, or deterioration. Promptly address any issues to maintain the safety and reliability of the electrical system. A disconnect switch is a manually operated device used to isolate a circuit or piece of equipment from its power source. It provides a visible means of disconnecting the circuit, allowing for safe maintenance, repair, or troubleshooting. In the context of transformer secondary conductors, a disconnect switch enables the isolation of the transformer from the load, preventing electrical hazards during work on the connected equipment. The selection and installation of a disconnect switch must comply with NEC requirements. The switch must be rated for the voltage and current of the circuit and must be suitable for the environmental conditions in which it is installed. The switch must also be readily accessible and clearly labeled to indicate its function. When installing a disconnect switch, it is important to follow a manufacturer's instructions and adhere to all applicable safety precautions. The switch should be installed in a location that is easily accessible and free from obstructions. The switch should also be properly grounded to prevent electrical shock hazards. Regular inspection and maintenance of disconnect switches are essential to ensure their proper functioning. Inspect the switch for any signs of damage, wear, or corrosion. Test the switch to verify that it operates smoothly and provides a positive disconnect. Replace any defective switches immediately. Here are some additional considerations for transformer secondary conductor disconnects. First, coordinate with other electrical equipment. Ensure that the disconnect switch is coordinated with other electrical equipment, such as overcurrent protection devices and control systems. This coordination helps to prevent nuisance tripping and ensures the proper operation of the electrical system. Second, label conductors and equipment clearly. Clearly label all conductors, disconnect switches, and other electrical equipment to facilitate identification and troubleshooting. Proper labeling reduces the risk of errors and improves the safety of the electrical system. Third, train personnel on safe work practices. Provide training to personnel on safe work practices for working on or near transformers and other electrical equipment. This training should include procedures for lockout/tagout, personal protective equipment, and emergency response. Fourth, keep accurate documentation. Maintain accurate documentation of the transformer installation, including wiring diagrams, equipment specifications, and maintenance records. This documentation is essential for troubleshooting and future modifications. It is important to note that the NEC is a complex and constantly evolving document. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrical contractor or engineer to ensure compliance with all applicable codes and standards. Let's break down specific scenarios and considerations related to transformer secondary conductor lengths and disconnect requirements based on the National Electrical Code. Conductor length exceeding 10 feet without raceway in situations where the secondary conductors of a transformer extend beyond 10 feet and are not enclosed in a raceway or enclosure. A disconnect switch is unequivocally required. This requirement aims to mitigate potential hazards associated with exposed conductors. The disconnect switch provides a means to energize the conductors for maintenance or in case of a fault, ensuring safety for personnel and equipment. The lack of a raceway leaves the conductors vulnerable to physical damage, increasing the risk of insulation breakdown, short circuits, and electrical shock. A disconnect switch acts as a safeguard, allowing for quick isolation of the circuit to prevent further damage or injury. When conductors are properly enclosed in a raceway, such as conduit or electrical metallic tubing, they are shielded from physical damage, moisture, and other environmental factors. This protection reduces the likelihood of faults and electrical hazards. Even if the conductors exceed 10 feet in length, the presence of a raceway may eliminate the need for a disconnect switch, provided that other requirements of NEC Article 450.3b are met. It is essential to ensure that the raceway is properly installed and maintained to provide continuous protection for the conductors. The raceway should be securely fastened, free from damage, and appropriate for the environment in which it is installed. When the secondary conductors are less than or equal to 10 feet in length, the requirement for a disconnect switch is generally waived, regardless of whether the conductors are enclosed in a raceway. This exception recognizes the reduced risk associated with shorter conductor runs, as the potential for physical damage and faults is lower. However, it is still good practice to provide some form of protection for the conductors, such as a raceway or enclosure, to minimize the risk of damage or accidental contact. Even with short conductor runs, consider the environment in which the conductors are installed. In harsh environments, such as those with high moisture, corrosive chemicals, or extreme temperatures, additional protection may be necessary to ensure the long-term reliability and safety of the electrical system. Even if not strictly required by code, a disconnect switch may be beneficial for maintenance and troubleshooting purposes. A disconnect switch allows for easy isolation of the transformer from the load, simplifying repairs, inspections, and other maintenance activities. This can save time and reduce the risk of electrical hazards during maintenance procedures. Always consult with a qualified electrical contractor or engineer to determine the specific requirements for your installation and to ensure compliance with all applicable codes and standards. They can assess the unique characteristics of your system and provide tailored recommendations to ensure safety and reliability. Regular inspections of the electrical system, including the transformer, conductors, and disconnect switch, are essential to identify any potential problems before they lead to failures or hazards. Inspection should be performed by qualified personnel and should include a visual examination of the equipment, testing of the disconnect switch, and verification of proper grounding and bonding. The NEC is updated regularly to reflect changes in technology, safety practices, and industry standards. Stay informed about the latest code requirements and amendments to ensure that your electrical system remains compliant and up to date. Attending training courses, subscribing to industry publications, and consulting with electrical professionals are all effective ways to stay informed. Adhering to the NEC requirements for transformer secondary conductor disconnects is essential for ensuring the safety and reliability of electrical systems. By understanding the length limitations, raceway requirements, and other factors that influence the need for a disconnect switch, you can minimize the risk of electrical hazards and protect personnel and equipment. Remember to consult with qualified professionals and stay informed about the latest code updates to ensure compliance and safety.